Okay guys, this is the level 2 practice paper, Caravan Holiday. Um, so obviously the theme is what it says, a caravan holiday. One thing to note, this is the first practice paper, is more of a sample practice paper that was produced at the beginning. And it is a tough paper. Some awkward questions and the layout can be quite difficult in places, so just be wary of that. Okay. Okay guys, so we're on to the first question here, and it's about working out the cost, okay, of staying in a caravan site for Mr. and Mrs. Wallace. So as usual, important to read the question carefully. Mr. and Mrs. Wallace are going on holiday to France. They need to choose between a caravan site in Loire and one in Dordogne. Mr. and Mrs. Wallace qualify for early booking discounts on both sites. Okay, so this table below shows the costs associated with Loire. Okay, so it's quite a complex table, and as regards your technique, always read the table first, always look at the information the table gives before you dive straight into the question. Okay, so if we look up here, you can see here it says that this table is showing the price per night. Okay, and that is important for later on. Okay, and the early booking discounts. Alright, so across the top here we have obviously the type of caravan. Its name is Rossini. There's one bed in it. It sleeps for 2 sharing, and there's the different costs for the different times of the year. Okay, so you can see there the year is split up into different months. This next bit shows the discounts. Okay, so if you stay between 7 and 11 nights, okay, you get these percentage discounts. You can see there for the different months of the year. Again, I'm not going to read out everything. You can see those for yourselves. There's also a different discount if they stay 12 or more nights. Okay, so the discounts are slightly higher. Alright, and then the question, now we've looked at the table, we look at the question and it states, how much does it cost to stay in Loire for 2 weeks in August with early discounts applied? Okay, so they're staying for 2 weeks in August, so that means it's this here what we're looking at. Okay, and the cost per night in August is £98, so that's our first key bit of information. The next key bit of information is to work out, well, which discount does that apply to? So they're staying for 2 weeks. Okay, and 2 weeks, we should hopefully know, is the same as 14 days. So that'll be 14 nights, which means the discount that applies to them is 15%. Okay, so at this point, we obviously need to work out the original cost. Okay, so the original cost, 14 nights, because that's 2 weeks, times by the £98, because it's £98 per night, which gives us an original cost of £1,372. Again, apologies about my writing. Right, so what are they actually going to pay? Okay, they're going to pay 15% cheaper than that, because the discount is 15%. So we have to work out now is 15% of 1,372, which we're going to do here. Now, depending on what way you were taught percentages, okay, there's loads of different ways of doing percentages. Anybody listening who was taught by myself, the way I taught you to do percentages or work out the percentage of amount was to turn the percentage into a decimal. So turn 15% to 0.15 and times by the amount. Of course, using our calculator at all times. Okay, and if you do that, you get the answer £205.80. Okay, so therefore the discount is £205.80. To work out what the Wallaces actually pay then, so it's the 1,372, and we then take away the £205.80 to get our final answer for this part of the question. And again, when we do that on our calculator, let's just do it a different color. The final answer that the Wallaces are paying for the Loire caravan site is £1,166.20. Okay, and always a good idea to put pound signs in answers. Okay, especially sort of final type answers. Okay, so that's how much it costs for the Wallaces to stay in Loire. Okay, the second part of the question then is working out basically how much does the same holiday cost in Dordogne. So again, from the previous question, remember that they're staying for 2 weeks. Okay, and this is a slightly different table in that, first of all, the big thing you probably spot straight away is the prices are in euros. Okay. The other thing that's different from the previous table is these prices are per week. Okay, and obviously, as we just said, in euros. Okay, and we can see it's obviously it's a simpler table. Okay, we've got Easter, May, June, July, August, September onwards, and the prices in euros. Okay. The other important bit of information is here that it says book 2 weeks, get the second week half price. Okay, and then the question underneath, now that we've looked at all the information, is how much does it cost to stay at Dordogne for 2 weeks in August with early booking discounts applied in pounds. Okay, right, so the prices are in euros, but our final answer has to be in pounds sterling. Now you need to ignore the pound sterling here just for the moment and work out, well, what is the price in euros first of all. Okay, so sometimes people are put off and they think they have to start turning the prices in the table into sterling. In theory you could, but it's too much work. You're better working out the cost in euros first. Okay, so for this we need to split it up into weeks. Okay, because the second week is half price. All right, so week 1 is simply going to cost 1,030 euros. Because remember guys, they're going for 2 weeks in August. Okay, and again, that's from the previous slide. This is still part of the same question. Okay, so week 2 is 1,030 euros. Week 2 is going to be half that. Again, because it says up here the second week is half price. Okay, which means 515 euros. So altogether in euros, this holiday costs 1,545 euros. Okay, and I'll try and draw a euro symbol neatly as I can. Okay, so we're nearly there. Okay, we've got marks so far by working out the price in euros, but to get the full marks, we now need to convert this euro amount into sterling. And to do that, we obviously need to know the exchange rate. Okay, and the exchange rate up here tells you that 1 euro is worth essentially 80p. Okay, or 0.80 pounds. All right. So how do we turn this here into sterling? So essentially, we're into conversion here. Okay. Now the tip I always give students is this: when you are converting an amount, okay, between currencies, you're always either multiplying or dividing. Okay, and if you do the wrong one, it should be obvious when you go to check it. Okay, now you know that 1 euro is 80 pence sterling. Okay, so that's less than 1 sterling. So you should really know that when you convert 1,545 euros into sterling, it should be less than that. Okay, 1 euro isn't equal to 1 sterling. Okay, and the way you do it in this one is actually multiply. So there's 80p in every euro, so you want to find out how many 80p's there is in 1,445 of them. So you multiply. By the currency, which gives you then your final answer of 1,236 pounds sterling. And again, final answer especially, stick in pound sign. Okay, now just a little thing here. Had we, for argument's sake, done the wrong thing here, say we had divided instead of multiplying, okay, what would we have ended up with? Okay, so we'll just do the wrong answer here. Sometimes it's important, okay, that we do the wrong answer as much as anything else, just to show how we should have spotted it was wrong. So let's say we did 1,445 divided by 0.80. Now remember, this will be the wrong answer, but it's easy sometimes to, when you know you have to either divide or multiply, it's easy to do the wrong one by mistake. Okay, so if we do that on our calculator, so 1,545 divided by 0.80, okay, we get this answer 1,931 £25. Okay, now you should know straight away you've done the wrong thing, okay, simply because you know the answer can't be more, okay, than what the amount is in euros. Okay, that doesn't make sense. How could 1,545 euros be the same as 1,931 sterling? Okay, whenever a euro is worth less than £1 sterling, so that you should spot straight away that's too high. That can't be right. Okay, and use a bit of trial and error and then do the right one. Okay, so when you're converting, you're always either multiplying or dividing. Okay, but if you do the wrong one, it should be obvious by looking at the exchange rate. Okay, so the final answer then for Dordogne is £1,236 sterling. Right, just to finish off this question then quickly, we've all the hard work done, but we just need to finish off by stating which was the cheapest site and what was the cost difference. Okay, so basically we worked out that Loire, I'll just do L for Loire. Okay, its cost was £1,166.20. Okay, and Dordogne, again just D for Dordogne, we worked out that it was £1,236 sterling. Okay, so which one was cheaper? Obviously Loire was cheaper. Again, sorry about the writing. Alright, and by how much? Then you have to find the difference between two numbers. The highest one, take away, so the highest one, take away the lower one. Okay, and that comes to £69.80. Okay, so that's what all 6 marks were for. Working out the cost of Loire, working out the cost of Dordogne, and then the difference between the two of them. And that finishes the first question. Quite a long question, worth 6 marks. Okay, but doable. Okay, so after quite a long question, we're into sort of a nice or shorter, easier one here. A travel website displays 20 ratings for the Loire site. They are listed below. Okay, so a rating of 1 is very poor, so that's the lowest rating. A rating of 10 is outstanding, and you can see there's 20 different ratings out of 10. Okay, and it's asked to calculate the range. All right, it's only a 1 mark question, but obviously what we need to know here is what range is. Okay, and range, we'll just put R for range, is the highest, just H, take away the lowest. That's all range ever is. Okay, and you can see here, so it's nice low numbers, which makes it a wee bit easier. The highest number is 10, and the lowest score was 4, which gives us a range of 6. So that's all range is. A group of data or a group of numbers, it's the highest number, take away the lowest number. Okay, the next question, well, you're asked to calculate the mean. So it's the same group of numbers again. Okay, it's the 20 ratings out of 10 that the Loire got. Okay, and you're asked to work out the mean this time. Again, mean is not hard. You just need to remember what it is and don't mix it up with the other averages, median and mode, basically. But mean is essentially the total divided by how many. Okay, and that is something we should know. Mean, range, questions, we should be getting right. Okay, so the total in this case, came to 161. So you add up all those 20 numbers, which comes to 161, and then you divide by 20 because there's 20 numbers. Okay, and then the mean come to 8.05. Okay, so again, just to recap, mean total divided by how many? Okay, so to finish off the question now, we need to compare the mean and the range of both locations. And to do that, they've told us, so we've worked out the mean and the range for Loire. This last part of the question, they've told us the range for the Dordogne is 3 and the mean is 8.5. And it says using the range and the mean of both these sites, advise Mr. and Mrs. Wallace which is the best site to choose. Okay, so again, remember these are scores out of 10. The 20 scores out of 10 we're still talking about. All right, and if I just okay, so L for Loire, D for Dordogne. Okay, and from our previous answers, okay, we know that the mean, I'll just put M for mean here, the mean for Loire is 8.05. Okay, and the mean for Dordogne, which we're after been given there now, is 8.5. Okay, the range, okay, for Loire, which we worked out in our previous question, is 6. And the range for Dordogne, which we've just been given here, is 3. Okay. So to answer the question, you would then write in a sentence. Again, I'm not going to start try to write in the sentence here with a mouse, but you can clearly see the most important thing here is mean, and the mean score out of 10 is higher in Dordogne. Okay, as you can clearly see there. All right. So that's the key thing there. Dordoigne's mean is higher than Loire. So based on that, okay, you advise Mr. and Mrs. Wallace to go to Dordogne. Okay, as simple as that, because Dordogne has the highest mean. All right. All right. Next question. Mrs. Wallace has a current balance of £385 in her bank account. She needs to pay the following holiday expenses immediately: a 30% deposit on an overnight stop costing £125, and the total ferry cost of £359.20. Mrs. Wallace thinks she has enough money in her bank account to cover these expenses. Is she correct? Okay, so we know how much she has in her bank account, £385. Okay, and we have to work out when we add these two costs together. Okay, is that more or less than what she has in her bank account? Okay, now this question probably could have been worded slightly better. Okay, this is the key bit here, this first one. Okay, the 30% off 125 is what it's asking there. Okay, so they could have maybe worded that to be a bit better to make that more clear. Okay, so the cost is not the full 125%, but the 30% of 125, which again we work out that way. And again, you may work out percentages a different way. Okay, so 30% of £125 comes to £37.50. So again, we turn the percentage into a decimal and we times by the amount. Okay, and then the total ferry cost is just £359.20. Don't have to do anything for that. Okay, so the money that she needs in her bank account to cover these costs is the £359.20. and the deposit, which we worked out as £37.50. Okay, and when you add those two costs together, it actually comes to £396.70. So is she correct? No, she's not correct. Okay, she was wrong. I think she had enough money. Okay, she's actually £11.70 short. Okay, and that answers that part of the question. All right, this next question has to do with time. Okay, and it's basically asking us what is the latest time okay, Mr. Wallace can leave to arrive in Dover. Okay. This question probably caused a bit of confusion. You're doing it because of this thing here. Leaves house at 8 a.m. That is actually wrong. Okay. And a wee bit confusing. Alright. Because if they leave the house at 8 a.m., as we'll discover, it's too late. Okay. So, in fairness, that's a wee bit confusing, a wee bit unfair that statement's there. Okay. Because it did throw people off. Alright. So the key thing is they're travelling to Dover. Okay. Home to Dover, as it says in that second bullet point there, takes 5 hours and 15 minutes. Okay. They must arrive at Dover 1 hour before the ferry departs, and the ferry departs at 14:25. Okay. So a bit of key information there. Alright. They must allow for 2 comfort breaks of 25 minutes and 3/4 of an hour for lunch on the way to Dover. Okay. So the best thing to do here is work out comfort breaks, lunch, okay, how long it takes to drive, add all that up together in hours and minutes. Is our best thing to do first. Okay. So the journey itself, okay, we can see here from this first bit, takes 5 hours and 15 minutes. Okay. So 5 hours, 15 minutes. Okay. The next thing then is they have 2 comfort breaks of 25 minutes each. Okay. Well, we can just in our heads realize that that's 50 minutes. 2 25 minutes is 50 minutes. Okay. And then obviously 3/4 of an hour for lunch. Okay. So we'll call that 45 minutes. 3/4 of an hour is 45 minutes. Alright. So then we basically add all that up then. Okay, just be careful with time. I'm not going to do a whole time lesson here, but we need to realize that there's 60 minutes in an hour. Okay, but if we just add the hours and minutes separately, okay, we get 5 hours, 110 minutes. Okay, the proper thing to do now then is turn everything into hours and minutes. So the whole journey altogether takes 6 hours, 50 minutes. Okay. So the question is asking, what's the latest time they can leave home at? Well, we know from here that they need to be in Dover for 1:25. Okay, because they want to be there an hour before the ferry departs, as you can see there. Okay, so they need to be at Dover at 1:25. So essentially, we have to count back from 1:25 p.m. What time is it? 6 hours, 50 minutes before that. Okay, so a couple of different ways you could go about this. Again, if I had taught you, I would tell you to go back in the hours first. So go back 6 hours, okay, first, and then count your minutes back separately. Okay, I think that's the best way of doing it. There is a couple of other ways of doing it. You may learn a different way, but you just need to be careful. Okay, and like I said, count back your hours separately from your minutes, and the time you will come to then. So if it's 1:25 p.m., 6 hours and 50 minutes before that, in the morning time is 06:35. Okay, or 25 to 7 in the morning, or 6:35 a.m. Okay, so not a difficult question, but you just have to be careful with time. Okay, in fairness, this leaves house at 8 a.m. I don't really understand why that's there at all, and that did throw a lot of people off. Okay, but again, it's a sample paper, so maybe it was just an oversight. All right. Okay, on to the next question. Mr. and Mrs. Wallace decide to look at weather records for 2012 to 14 for the Loire, and they're dying to help them decide where to stay. They prefer dry weather. Okay, so that's the sort of the key thing to answer in this first part of the question. The average rainfall amount in millimeters for August 12 to 14 has been recorded in the table below. Okay, so it's a fairly simple table. You have the years, okay, 12, 13, 14, and the amount of rain, okay, in millimeters. Okay, so Loire 15, 12.3, 15.9, Dordogne 11.6, 8.1, and 10.8. Okay, now there is a mark here, and I'm not even going to bother. It's such an easy mark by writing it out. Advise Mr. and Mrs. Wallace which is the preferable place to stay. Okay, well, you know they like dry weather, and you can clearly see that Loire has higher rainfall than Dordogne, so that's where your one mark there. You simply advise that they go to Dordogne. Okay, and like I said, not even going to bother writing that out. Okay, but that's what the one mark was for. The other marks are for this bit here. Essentially, we're asked to draw a bar chart. Okay, now this online voiceover is done through PowerPoint, so we can't really draw a bar chart properly. Okay, it would be too messy. So on the next slide, you'll see that the bar chart is actually drawn out. Okay, and we'll just discuss what you need to do to draw a bar chart properly. Okay, right. So this here is a bar chart. Okay, and it's a dual bar chart. Again, apologies about my writing. Okay, it's a bit rough and ready, but you'll see the key thing here about a dual bar chart is you're comparing two things. Okay, and at the bottom here you'll see we have obviously the 3 years, 12, 13 and 14, and each year had two answers because there's two places, Loire and Dordogne. Okay, now if this was a lovely neat bar chart, you'd have lovely different colors. Okay, you can see I've just used Loire as sort of stripy bars and Dordogne, okay, just blank bars. But it's important when you're doing a dual bar chart that you show a key, okay, showing the difference between the two. Okay, so this little key here is important. All right, or you wouldn't know which is which, basically. All right. Now the key to doing any bar chart is probably the vertical axis. Okay, so along the side here, going up and down. All right, and selecting basically the correct intervals. Okay, now most pieces of graph paper, okay, do tend to have roughly 15, 16 squares. Okay, and so then you need to decide, well, what interval can you go up in? And the key is to look at your highest number. Okay, now I can't flick back to the previous table again, but the highest number was roughly 16. So therefore you need to be thinking we've enough room to go up in ones. So you can see here we all went up in ones. Okay, the whole way from 0 up to 16. Okay, so I'll not get into the whole bar chart lesson again, but your natural intervals tend to be 1s, 2s, 5s, 10s, things like that there. But here we can go up in ones. Okay, now the key thing as well here, and it's hard to see, okay, and here, but each big square, okay, we went up in ones here, and 10 little squares. Okay, so that meant that each little square was worth 0.1. Okay, so again, it's too hard to see here, it's not big enough, but if you can imagine each of those little squares, okay, 0.1, 0.2, 0.3 and so on, okay, so in between. Alright, so you have to be that accurate because there was decimals in the rainfall. Alright, so we can see here 2012, okay, in Loire it was exactly 15, okay, in Dordogne, sorry, it was 11.6, okay, so you can see here we go up to 11 and then 6 little ones, okay. 2013, okay, was 12.3, so up to 12, okay, and then three little ones. Okay, 2014, you can see here 15.9 and 10.8. So you can see just one below 16 and 10.8. So each little one was worth 0.1. All right, so that's a tricky enough bar chart. The fact that it's a dual bar chart, okay, and also the fact that it's decimals in it, but it can't go like that in level 2. The other important thing about a bar chart, okay, is to have everything labeled. Okay. Title first of all. A lot of people leave out title, so just a title which is related to, okay, what the bar chart's about. Make sure you label both the vertical and the horizontal axis. Okay, so this is obviously the rainfall in millimeters. Okay, these numbers represent millimeters. So in different bar charts, it could represent money. So it would be a pound sign you would put there. Okay, or it could be marks in a test, whatever. All right, and then the horizontal axis, okay, is the years. You can see the years are labeled there. Okay, and in fact, in fairness, I think you'd be okay with the marks, but it probably will be a good idea just to put in an overall heading of year there as well. Okay, so a bar chart, key thing is selecting your correct intervals along the side, drawing in your bars. Always a good idea to put spaces, so there's a natural place to put a space there, obviously between the sets. If it's a dual bar chart like this one, show a little key showing which is which. Okay, and like I said, most bar charts are 5, sometimes 6 marks. So a lot of marks, okay, for something which is doable, but you need to make sure you remember to put all those little things in to make sure you get the full marks. Okay. All right, the next question then is about, it's essentially a formula question in the second part of it, but in the first part of it here, slightly different. We have to compare methods. So we'll just read the question. Do a temperature. Mrs. Wallace has heard that the average monthly temperature in Loire in August last year was 70 degrees. Okay, so that's 70 degrees is the important number here. She knows of 2 methods for changing temperature into degrees Fahrenheit to degrees Celsius. Okay, so the 70 degrees Fahrenheit, she wants to turn it into Celsius. Okay, and there's 2 methods. Okay, so method B is obviously going to be in the next slide. Method A, as an estimate, she says subtract 30 from the given temperature and divide by 2. So that's fairly simple. Okay, so the given temperature is 70. Okay, so it says subtract 30. So I just change that to red. So 70, take away 30, which comes to 40. Okay, and then we divide the 40 by 2. Which comes to 20. So she is saying that if you use that, I suppose you call it a quick method, okay, that 70 degrees Fahrenheit is roughly the same as 20 degrees Celsius. Okay. Okay, so the second part of this question is method B, where we use this formula, okay, to turn 70 degrees Fahrenheit into Celsius. Okay, so this is a very common formula, comes up a lot. So it's C equals 5 bracket F minus 32 close brackets over 9. Okay, where C is the temperature in Celsius, so that's going to be our answer, and F is the temperature in Fahrenheit. Okay, and just important to note, it's always handy to put, you realize that F is 70 in this case, as stated in the previous question and here as well. Okay, now those of you that have been taught by me will know what is our first step always in formula, and it is substitution. We do no working out whatsoever, okay, in a formula question in the first step. You simply rewrite the formula, but replace all letters with their numbers, okay, within the formula. Now, if you look at this formula here, within the actual formula, there really is only one letter, which is F, which is 70, okay? But we do that, okay? Don't try and do it too quickly, okay? You get no extra marks for flying through a question. Okay, and that is our, substitution we're doing. Okay, so we replace the F with the 70, close the brackets, okay, over 9. And that's our substitution done. Okay, very important step that. Yeah, sometimes there's more letters within a formula, okay, but that is our substitution. All right, and now we start to break it down. Okay, we think of, right, what do I do first here? Well, what you should be thinking here is we have a calculation inside brackets. All right, what does inside brackets mean? Okay, it means you do it first in formula, as we've often discussed in formula lessons. All right, so that is what we do. And 70, take away 32, fairly simple. taken away calculation is 38. So we rewrite again this time with our answer inside the brackets. So we have 38 inside brackets over 9. Now, what you need to realize here is, so I just run out of room, so I'll just have to hold the arrow up going to here. So we essentially have a top calculation and a bottom number, okay, or a top number and a bottom number, okay. And at the top we have 5 and 38 stuck together. Okay, it's inside brackets, but the brackets are and the 5 are together. So what does that mean? Okay, and again, if you're sitting in front of me, you would tell me that means you multiply. When things are together, okay, in formula it means you multiply. So 5 bracket 38 means 5 times 38. So you multiply the 5 and the 38, which will give you 190. Over 9. And this then gives us, okay, our final calculation. So in formula it looks a bit like a lopsided fraction, okay, we've got a number over another number, okay, but it's a big number over a smaller number. Even though it looks like a fraction, the calculation this is telling us to do in formula is divide, and we always divide the top number by the bottom number, okay. So it's 190 divided by 9, okay, which gives us our final answer of 21.1 degrees Celsius. Okay, so using the formula we have converted 70 degrees Celsius into 21.1 degrees, or sorry, 7 degrees Fahrenheit into 21.1 degrees Celsius. So method B is a more accurate method. Okay. Right, we're on now to task 2 of the exam, which is the garden. Okay, and this particular question here is essentially a real life to scale question, which hopefully will ring a bell from when we did this during lessons. So to read the question, Emma has a rectangular plot of land measuring 8 meters by 6 meters. She wants to fit 3 raised flower beds in this plot. Each raised bed, is 3 meters long and 1.5 meters wide. There needs to be a pathway of at least 1 meter wide around each raised bed. Using the graph paper opposite, draw a scale plan of the plot with the 3 raised beds suitably positioned. Use a scale of 1 to 50. Okay, so quite a lot of information there. Okay, but what we need to realize here is, okay, these measurements, these meter measurements we're given here, they are all real life measurements. Okay, and the key for us is we need to make those real life measurements small enough so they fit onto a scale drawing. I know it's stating the obvious, but we can't draw 8 by 6 meters on a piece of paper. Okay, we need a piece of paper the size of the actual garden. So we need to make real life measurements smaller. Now, how do we make measurements smaller? We divide. Okay, what do we divide by? And the key thing here is we divide by the scale, which in this case is 1 to 50. So what you need to realize, what this question is asking you is to make everything 50 times smaller. Okay, so that is essentially what we do in what we call a real life scale question. Okay, we make everything smaller by dividing by the scale. Alright, now as you'll see from our notes previously, there's essentially 2 steps to doing this. Alright, the first step is to convert everything into centimeters. Now, hopefully this makes sense when you think about it. When you draw a scale drawing, what are you going to be using? You're going to be using your ruler. Alright, and what are you going to be using on your ruler? The centimeter measurements. So the best thing to do is to convert all your real life measurements into centimeters. So see all these meter measurements we're given? We need to convert all those into centimeters. Alright, and when we do that there, so up here, okay, we're obviously going to have 800 centimeters. Again, sorry about my writing. By 600 centimeters. So all these green measurements are centimeters. Alright, each bed then, that becomes 300 by 150 centimeters. And then the pathway between each of them has to be 100 centimeters. Alright, so those green measurements are our conversion. Okay, we've converted everything now into centimeters. However, the key thing here to realize, guys, is we have not made anything smaller yet. We have just converted into centimeters. Alright, we haven't changed the actual length of anything yet. We haven't made those smaller. So that is our second step then. Okay, the second step when you're going from real life to scale is then we divide by the scale. Alright, so therefore all these green measurements then we have in centimeters. Alright, we have to divide all those by 50. In this case the scale is 1 to 50. Now, the scale could literally be anything. Alright, if the scale was 1 to 100, you would divide by 100. If the scale was 1 to 200, you would divide by 200 and so on. Alright, but the key thing is you divide by the scale, which in this case is 50. Alright, so we'll just do these in purple. Again, sorry, this is getting a wee bit messy, but we then go and divide all these green measurements by 50. So the 800 will become 16. The 1600 will become 12. And again, these are all centimeters. 800 centimeters divided by 50 is 16 centimeters. 600 divided by 50 is 12 centimeters. 300 here, you divide it by 50, it'll become 6. The 150 will become 3, and then the little pathway that goes in between them, divide it by 50, that'll become 2. So these purple measurements are now our key measurements. That is our working out done. This is what we use now when we go to draw with our ruler. Okay, so the plot itself will be 16 by 12 centimeters. The beds inside the plot will be 6 by 3 centimeters. And then the little pathway in between them, alright, has to be 2 centimeters. Alright, and those are the measurements we use. You'll see in the next slide what the scale drawing will actually look like. Okay. Right guys, so this is the scale drawing from the previous slide where we worked out all the calculations. It's too hard to draw on this PowerPoint, so it's better just to show the completed scale drawing to explain how it was drawn. Unfortunately, we can't flick between slides. So the first thing about a scale drawing, guys, is you need to put in the scale. So you'll see this up here. Alright, that'll always get you 1 mark by simply putting the scale onto the scale drawing. You usually put it up into the right hand corner. So the scale is 1 to 50. A scale drawing will not make sense, alright, without a scale on it. Defeats the whole purpose of what a scale drawing is. Alright. So the next thing you'll see here is the outside plot of land. Alright. So the plot on the outside, alright, its real life size was 8 meters by 6 meters, but we divided that by 50 and it's now 16 by 12. Alright, and you'll see that the graph paper here is 1 centimeter graph paper, so essentially 16 squares by 12 squares. Alright, just rub that in. And then the next thing we had to put in was the raised beds. Now each raised bed was 3 meters long by 1.5 meters wide, and then when we made that 50 times smaller, that becomes 6 centimeters by 3 centimeters. Alright, so essentially when it comes to the graph paper, 6 big squares by 3 squares. Alright, and they're all the same size, so 6 by 3. Now this was probably the most tricky bit, okay, was the fact that there had to be, again if you look back at the other slide, there had to be a 1 meter gap between each bed, which meant that each bed had to be 2 centimeters apart, or 2 squares apart. Alright, so you can see there are 2 squares apart. Alright, now that could be tricky enough because you can see a lot of people here that don't think that you can turn the plots around. So the only way that was really possible, alright, was, I just want to get rid of these lines here. The only way that was really possible was with this sort of long ways one here. Alright, this plot here. So you can see there we sort of put it on its side. Alright, there wasn't really room to put them all vertical, if you like. Okay, so we had to put this one horizontal. Alright, and that's sometimes where a lot of people lost the mark, because they just didn't have the 3 beds 1 meter apart, or 2 centimeters on the scale drawing. Okay, so but again, that will only cost you 1 mark. If you had everything right and the only thing you had wrong, alright, was the fact that you had them spaced out right, would only cost you 1 mark. Alright, but the key thing here is we made everything 50 times smaller. Alright, and on the previous slide where we did all that calculating, the 2 steps, convert everything into centimeters and then divide by 50, and that gives you the measurements to then draw the scale drawing. Okay. Alright guys, this next question then states, raised beds are 3 meters long, 1.5 meters wide and 85 centimeters high. Beds need to be filled with topsoil to within 10 centimeters of the top of the container. Topsoil is delivered in 1,000 litre bags. How many bags of topsoil will Emma need to fill all 3 raised beds? Justify your answer using calculations. And then it gives us this little bit of information here where it tells us that 1 meter cubed is the same as 1,000 litres of topsoil. Alright, so quite a bit of information there, but what needs to be sort of popping out at you here is that volume is the key to doing this question. Alright, because each raised bed is 3 meters long, 1.5 meters wide and 85 centimeters high. So this is essentially a volume question. Alright, so I'll just put V for volume. And again, what you need to realize here is, based on these measurements, each bed has a length, a width and a height, so it's essentially a cuboid. Alright, and a cuboid are cubes. To get the volume of these shapes, it's a simple enough formula. It's length times width times height. And you've probably seen it written like that before somewhere. LWH, length times width times height. When things are together, it means you multiply. Alright, so that is essentially the first thing we have to do here, is work out the volume of each raised bed. Now, as usual in level 2, alright, it's not quite as simple as it seems, in the sense that when they give you measurements, so we have the length here, 3 meters, the width 1.5 meters, but they have given the height in centimeters. Alright, and as we've did previously in lessons to do with measurement, you can't get areas or perimeters or volumes of any shapes unless all sides are in the same unit. Alright, so we need to change 85 centimeters into meters. That's the first thing we need to do. So the actual height, alright, of each raised bed is 0.85 meters. Alright, now even that isn't what we use to work out the volume of each raised bed, because essentially we're not working out the volume of the raised bed, we're working out the volume of the topsoil. Okay, and that's the slight difference here. Alright, it's actually not the volume of the actual, if you can imagine the box that makes up the bed, it's the volume of the soil that goes into it. Alright, and it tells us here that each bed is filled within 10 centimeters of the top of the container. Okay, so that means we only fill it, or Emma's only filling it up to 75 centimeters. Which essentially means the height then of the topsoil is 0.75 meters. All right, so perhaps we didn't have to do the converting up here. We could have waited obviously down here, because the height then, the key height is 0.75 meters, because just to repeat myself, we are working out the volume of the topsoil, not the volume of the container itself. All right, so to work out the actual volume of topsoil needed, so it's 3, which is the length, 3 meters, times the width, 1.5 meters, but the height we actually use is 0.75 meters. So obviously very easy there to use 0.85 here, okay, instead of 0.75. All right, you still get marks, okay, if you use 0.85 and did everyone else right, but obviously to get all the marks, you needed to realize that it's 0.75 meters you use for the height. All right, so we multiply those three things together, and that will give us 3.375 meters cubed. All right, so each raised bed needs 3.375 meters cubed of topsoil. Okay, now again, what we need to realize here is there are 3 raised beds, as it says here, and we need to work out how much topsoil we need for all 3 of them. So again, that's another little bit of information that sometimes people leave out. Again, the importance of reading the questions. So we need to multiply all this by 3. All right, when you multiply that by 3, you then get, just do it in a different color. For all 3 beds, we need 10.125 meters cubed of topsoil. All right, so that's the key number now. All right, so if we bring that over to here, if 10.125 meters of cubed of topsoil is needed, all right, that means we need therefore 10,125 liters of it, because in here, as we said before, 1 meter cubed is 1,000 liters, so 10.125 meter cubed will be 10,125 liters. All right, so the question was, the overall question was that how many bags of topsoil does Emma need? Okay, and each bag is 1,000 liters in it. Okay, so therefore she needs 11 bags. 10 bags isn't going to be enough. That's the final answer. All right, so there's quite a lot of places there where you could go wrong. All right, but again, volume, length times width times height. Make sure everything is in the same unit, and at least at that point you'll definitely get marks as long as you get the volume. All right, short question, just a follow-up question from what we just did, and that is to show a check calculation from the previous question. All right, so a general thing about check calculation, guys, is essentially what you're doing most of the time is doing an inverse calculation. All right, so you pick a calculation from your previous working out and you reverse it to check that it's right. All right, now you want to keep this as simple as possible. So when we go back to the previous slide, probably one of the easiest calculations we had was this one here. All right, when we were working out how much soil was needed for the 3 raised beds, and it was 3.375. Again, sorry about my writing, not getting any better. Times 3 equals 10.125 meters cubed. All right, so that's the original. Now, you wouldn't usually write in the original calculation on the check, but obviously we can't, like I said before, we can't flick back to the slide. All right, so this is the calculation we're going to check, this red one, okay? And so the blue here is going to be the check. So we are checking essentially a multiplying calculation. And what's the opposite of multiplying? Dividing. Okay, so to inverse calculation, you go backwards and do the opposite. All right, so if that times 3 equals that, okay, then this answer divided by 3 should equal this here. So we go backwards. All right, so the answer becomes the first part of the check calculation. So 10.125 divided by 3 equals 3.375. All right, and you do it on the calculator just to make sure that's correct, because the whole point of a check is, if that wasn't correct, then that tells you that you've went wrong. All right, but essentially, and you remember from our check lesson, to check any calculation, you do an inverse calculation. So you go backwards and do the opposite. Okay, so next question, 2D. Okay, this was a pretty tricky question. It may seem obvious when you're looking at the sketch, but it was a very hard question to do without really drawing a sketch. So it says Emma wants to grow cabbages in one of the raised beds. Raised beds are 3 meters long and 1.5 meters wide. There will be at least 30 centimeters between each plant and also between plant and border. Okay. Packs of plants are sold in multiples of 6. Calculate how many plants Emma will need to buy. Start working below with sketches if necessary. Alright, so when they tell you to use a sketch, they're sort of hinting at you need to draw a sketch here. Alright, so this is drawn from scratch. It was just completely blank. Alright, but the first thing you should have done was draw the outside. So you know that it was 300 centimeters by 150 centimeters. Now it's just a sketch. It doesn't have to be drawn exactly right. Alright, obviously you can't draw, 300 by 150 centimeters. You haven't a page big enough. But just realize that the sketch, that's what it represented. Alright. Now the key thing you need to say to yourself here was, at 30 centimeters, how many 30s is there? Okay, going across and going down. So you can see here, all these represent the 30s. Essentially there was 10 of those. Alright, and then going down then, there's 5. Okay, so 5 30s going down. Alright, because you're doing everything with 30 centimeter gaps. There has to be 30 centimeter gaps between everything. Alright, and the key thing here was, alright, if you think of this like a grid, alright, the first cabbage, that is where the first cabbage could be planted, because it's 30 centimeters away from everything. Okay, because there has to be a 30 centimeter gap between the plant and the border. Alright, and then from there, essentially just fill in all your plants. So going across, you can see each of these, sorry, just to be clear, each of these red dots, I'm just going over them again, all represent a cabbage plant. So going across, you could fit in 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if you look at those 9 dots, I'm just after refilling there. Okay, they are all 30 centimeters apart, and they're also 30 centimeters from the outside, from the border. Now going down, so we can save this one again, 2, 3, 4. Okay, so like I said, going down, 4 cabbage plants fit in. Alright, so 9 across fit in, and 4 going down fit in. Alright, now at this stage, okay, you can do 2 things. You can start drawing in all these cabbage plants again and then count them all individually, or you can just realize that you have 9 rows of 4 plants essentially, or 4 rows of 9 plants, whatever way you want to look at it. So you times the 9 and the 4, which comes to 36. So you need 36 plants altogether. Alright, and it says that the bags come in multiples of 6. So how many bags, and that is the final question, or how many packs. Okay. Alright, so there's 6, so 36 divided by 6 is 6. So your final answer is 6. So you need 6 packs of plants. Okay, so a tricky question, but those type of questions always draw a wee sketch to help you. And once they even mention sketches in the question, they're nearly telling you to do this question you need to draw a sketch to help you visually. Alright. Alright guys, this question: in another raised bed, Emma wants to plant strawberries. She needs 20 plants. Bobby's Garden Centre sells packs of 4 plants at 180 per pack. Sunny Garden Centre has an offer of 50p per plant, or buy 4 get 1 free. Alright. So she needs 20 plants. Alright. So Bobby's first of all, so with these two places we need to compare essentially. Alright. So Bobby's has 4 plants at 180 per pack. Alright. So just put B for Bobby's here. Alright. So 4 plants per pack. Alright. That means she obviously needs 5 packs. Okay, from Bobby's. So that'd be 5 times 180. Which comes to £9. Alright, so I know I skipped past there, but you should be able to mental math the fact that if there's 4 plants in 1 pack, okay, then 5 packs will have 20 plants. So that's where the 5 comes from. Okay. So the next one then we have to work out is the Sunny. Just put S for Sunny here. Okay, wee bit trickier. Alright, it says here that Sunny Garden again has an offer of 50p per plant, or buy 4 get 1 free. Alright. So what you need to realize here is if you buy 4 and get 1 free, okay, that means that you will be paying £2 for every 5 plants from Sunny. Let's make that Sunny. Alright, again, sorry about my writing. So £2 for every 5 plants. Alright. So how many sets of 5 do they need? They obviously need 4 sets of 5. Okay, so they need to do this 4 times. Alright. And 4 twos comes to £8. Alright, so therefore Sunny is the cheapest. Alright, so an easier type question, still tricky enough. You just have to give it careful thought and make sure you read the question correctly. Alright, but again, it's just using sort of a combination of mental maths there, bit of multiplying to realize which is the cheapest. Okay guys, next question. Emma creates a tally chart to record the sightings of various bird species in her garden on a day in June. Paul sees a bird in Emma's garden on the same day as the sightings are recorded. Using the tally chart below, calculate the probability that the bird will be a thrush. Express your probability in 2 different ways. Alright. So, probability. Now, again, going back to the probability lesson we did earlier on in the year, the way I taught you this was to make sure that when you're answering a probability question, you answer it in the form of fraction, decimal, and then percentage. Because although this question doesn't do it, in the papers you'll be doing after this, you'll see that most probability questions want the answer in percentage. I know the sample one asked for it in 2 ways. We're actually going to do it in all 3 ways, but it seems to be very common in later on exams to want the answer in percentage. And the best way to work out a percentage in a probability question is to do it in this order: fraction, decimal, percentage. Alright. Now the question is asking us, what's the probability that the bird will be a thrush? So we need to work out the fraction of these birds in this tally chart that are thrushes. Okay. And to do that, we need to know the total basically. Okay. And that is the first thing you need to do here, is work out the total. Alright, how many birds was there altogether? Okay. And hopefully we can all just read a tally chart here. Okay, properly. So, sorry, just get the right color here. So magpie There's obviously 19 of them. So 5, 10, 15, 4 is 19. Blue tit, 5 and 3 is 8. Finch, 5 and 5, 10. The wood pigeon, 5, 10, 15, 20, and 4 is 24. The robin, 15. Finally the thrush, 4 of those. Okay, so we then need to add all those together to get the total. Alright, and when you add those all up, the total amount of birds comes to 80. Alright, so for us to work out the probability that the next bird will be a thrush, our two key numbers is 4. Sorry, wrong color. Is 4. I wrote the 4 by mistake. So our key numbers here is 4 and 80. Now, what you need to be thinking in your head here, guys, is the chances of the next bird being a thrush is 4 in 80. So that is the phrase you need in your head, 4 in 80. So those are the two key numbers. Now you just say to yourself simply, well, 4 in 80, what will that look like as a fraction? Well, obviously 4 over 80. Now I know that can be simplified, but we'll just leave that for the moment. Now, how do we turn any fraction into a decimal? Okay, now those of you who've been specifically taught by me will be sick of me going on about this. But to turn any fraction into a decimal, you can do it 2 seconds in your calculator, and that is you divide the top number of the fraction by the bottom. So top divided by bottom. Okay, and if you do 4 divided by 80, you will get 0.05. Alright, and then once we have that, we should be able to mental maths, because the way we learn percentages, we actually used decimals. Alright, so 0.05, you should be able to mental maths without doing any working out that 0.05 is 5%. Alright, and there's our answer in all 3 ways. Okay, fraction, decimal, and percentage. One wee slight thing here, okay, the fraction isn't simplified, but it doesn't have to be simplified to work out the decimal and the percentage. Alright, so a lot of people get caught on the go 4 over 80 and they think, oh, I need to simplify that first before I do the decimal. 4 divided by 80, okay, the simplified fraction is 1 over 40, okay, or sorry, 1 over 20, but 1 divided by 20 will give you the same thing as 4 divided by 80. Okay, so I always encourage you to use either decimal or percentage. But like I said, going forward, most of the questions seem to be asking for the answer in percentage. Okay, so that's the key there. How do you get to a percentage answer for probability? And that's the best way. Fraction, then decimal, then percentage. And just to remind you, the key step when you're turning a fraction into a decimal, divide the top by the bottom. Okay. Alright guys, on to the last question. And this is basically a ratio question. So it says, Emma finds the following recipe for bird feed on the website. Make your own bird feed by mixing 3 parts seed to 2 parts nuts. Emma already has 2.7 kilograms of seed but no nuts. The local pet shop sells nuts in 1 kilometer bags at 68p per bag. How many bags of nuts will Emma have to buy to mix all the seed she already has with what will cost her, and what will it cost her? Okay, so quite a complicated question there. Alright, so essentially we have a ratio here of making bird feed. Alright, and it's always a good idea to write the ratio. Okay, so it's 3 parts seed to 2 part nuts. So I think it's always a good idea to write the ratio out like that, and we know that the 3 belongs to the seed, okay, and the 2 belongs to the nuts. Alright, and it's telling you here that Emma already has 2.7 kilograms of seeds. but she has no nuts, and that's what we're trying to find out. How much nuts does she need? Alright, so again, just for a visual aid, it's always a good idea then just to put the 2.7 kg underneath there. So essentially what we need to find out is this here. Okay, what's the equivalent nuts that's needed along with 2.7 kilograms of seed? Alright. Now the key here as always, and you remember from ratio lessons, is finding out one part. Alright. Now we know, if we look back up here, okay, this part, we know that 2.7 kilograms represents 3 parts. And once again, sorry about the writing. Alright, so the key to any ratio question is one part. So we need to find out, well, what weight represents one part. Alright, so if 2.7 kilograms represents 3 parts, okay, then what you need to realize here, then therefore to find out one part, we need to divide 2.7 by 3, which gives us 0.9. Alright, so that is the absolute key to doing any ratio question. Finding out what one part is. Okay, so again, just to recap, up here, it told us basically that 3 parts is worth 2.7 kilograms. When they give us the information for the seed, they told us that 3 parts is worth 2.7 kilograms. So if 3 parts is worth 2.7 kilograms, 1 part has to be worth 0.9 kilograms. Alright, and then from here, we can then work out how much nuts we need. Alright, so we know that 1 part is 0.9 kilograms. Alright, so therefore 2 parts will be our 0.9 times 2, which equals 1.8 kilograms. So therefore, if Emma has 2.7 kilograms of seed, she therefore, to match up with that, she will need 1.8 kilograms of nuts. Alright, and that's most of the question done. However, the last thing is it's asking how much does she pay for the bags of seed. Alright, so there's this extra wee bit at the end. Alright, so you can see it says here that 1 kilometer bags at 68p per bag. Alright, so she is going to need therefore 2 bags. Okay, she needs 1.8 kilograms, so therefore she needs to buy 2 bags. So I'm going to have a wee bit left over. So she needs 2 bags at 68p per bag. Which means then the bags of nuts are going to cost her £1.36. Alright, so a tricky enough question for a ratio question, but the key thing again, I know I'm repeating myself, but it is to find out one part. You use the information that they give you to try and find out what one part represents. Alright, and that is always your starting point to doing a ratio question. Alright. Okay folks, that's the end of that paper. Okay, hopefully you found that useful. What I will say is that is a tricky level 2 paper. Alright. A lot of awkward questions in it. We're always aiming for that magic mark of 65%, okay, as sort of average pass mark for essential skill level 2 papers. However, if you scored in around 50% on that paper, because of its difficulty, if you scored in around 50% plus, then that is a very good mark on that paper. And if you did that, well done. If you scored below 50%, don't be too disappointed. Okay, it is a tough paper, but it's a good starting point as well to use for revision. Alright, and hopefully you'll see your marks increasing, as this is only obviously the first paper. Okay, thank you for taking the time of going through that, and hopefully you found it useful.